It's Algebra 2, Spring Test number 1. Study guide is part 2, beginning on number 10. Okay, so we're starting to go backwards from the stuff we did. All of that was harder stuff to do. This is easier. X squared plus 11x plus 24. You're just making two binomials out of it. X times x. Your factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Which pair gets you to B's value? Which pair gets you to 11? The only ones that when you put them together get you at 11 is this pair right here, 8 and 3, or 3 and 8. So when you put those in, 3 and 8, the next thing, this tells you the signs are the same. This tells you they both plus. So plus 3, plus 8. There's your factored version, x plus 3, x plus 8. Number 11, solving the equation. Okay, we know how to do, please excuse my dear Aunt Sally, we know how to undo addition with subtraction. We know how to undo multiplication with division. And we know how to undo radicals like square root symbols by squaring things. You still work your order of operations, please excuse my dear Aunt Sally. And when you undo, you still work backwards. So you look for any addition and subtraction first. That says the square root of C minus 10. So you cancel out minus 10 by adding it on both sides. If you add negative 8 plus 10, you get positive 2 equals the square root of C. There's no multiplication and division next. So you get to this next step that we sort of introduced in this class, the exponents and radical step. We cancel out radicals by squaring the square root, and it'll cancel it out. That's how, just like you cancel out subtraction with addition. If you square that side, you square the other side. 2 squared is the number 4, so C is equal to 4. Number 12 said the square root of C plus 5 is equal to 5. You can't subtract 5 first because that square root, that radical symbol, acts like a grouping symbol. So as far as its Q, it puts it all the way in the top where parentheses go to undo. So what you need to do is you need to cancel out this entire thing by squaring it first. If you square that and you square the other side, it'll cancel this out and leave you with C plus 5 equals, remember 5 squared is not 10. It's 5 times 5, which is 25. Then you undo the plus 5 part by subtracting it on both sides, and C's value is 20. Where it says to check your solution for both of these, if you plug in 4 for number 11 right here, you get the square root of 4, which is 2, and 2 minus 10 gives you negative 8. That's true. Same thing with this one over here, number 12. We just got 20. If you plug in 20 right there, 20 plus 5 is the square root of 25, which is in fact 5. That's another true statement. Number 13 says solve the equation and identify any extraneous solutions. That just means when you plug them back in, if you get something that's not true. One of these is in fact extraneous when we do this one. X equals the square root of negative 5x plus 6. What you want to do is you want to get rid of the square root symbol first by squaring it. If you square that side, you square the other side. Now what you have is x squared equals negative 5x, because this goes away, plus 6. In order to solve an equation like this is a quadratic, you need to make it say equals 0 on one side. It's easier to make it equal 0 away from the x squared side. So what we want to do is this right side over here, this side, we want to make that one say equals 0. In order to do that, we want to move everything else to the other side. Minus or negative 5x, when you move it to the left, becomes positive 5x. So what we have on the left is x squared. What we have on the left is x squared plus 5x. And I tried to move all that over, and I didn't move enough, I guess. Plus 5x. When we move the plus 6 over by subtracting it, we get minus 6 equals 0. From there, factor out x squared plus 5x minus 6. We know how to factor things out. Trinomials out, you make 2 parentheses. X times x, your factors of 6 are 1 and 6 and 2 and 3. Which pair gets you to 5? Both of them does. So what you need to do is you need to look at your sign in front of 6, negative. That tells you they're going to be different. So you need to use the one that subtracts. 6 and 1 is going to be the pair we want to use. That tells you they're different. This tells you the bigger one is plus. 6 is bigger, so it's plus. 1 is smaller, so it's minus, and that all equals 0. So what you have is two problems. Both of them are two small problems, give you 0. X plus 6 equals 0, and x minus 1 equals 0. We know how to get x by itself for the first one. We subtract 6 on both sides, so we get negative 6. And we know how to get x by itself on the second one. We add 1 to both sides. We get x equals 1. So we have two possible answers, negative 6 and 1. Now where this extraneous solution parts comes in, if you plug in these values, what do you get? If I plug in the number 1, for example, 1 equals negative 5 times 1 is going to be negative 5 plus 6. That gives us 1 equals the square root of 1. Is that a true statement? Is the square root of 1 equal to 1? Yes. If we plug in the negative 6, however, we get negative 6 equals negative 5 times negative 6 is going to be 30 plus 6. We get negative 6 equals the square root of 36. Is that one a true statement? Yes. The square root of 36 can also be negative 6 because negative 6 times negative 6 is 36. So this is not going to be an or problem. This is going to be and. Both of those are correct, negative 6 and 1. However, there are instances where when you plug them back in, you'll get to something that is untrue at the end, and it will not work. And you're going to have to cancel out that one. Right, y equals negative 2x squared plus 12x minus 20 in vertex form. In order to make vertex form, you need to have a perfect trinomial. In order to have a perfect trinomial, negative 20 is not going to work. We need to move negative 20 over. It says minus 20, so when we add 20 to both sides, we get y plus 20 equals negative 2x. This is the one I want to cancel. This is the one I don't want to do. Thank you. There's another vertex one in a minute I want to go over. Number 15 says solve the equation by finding square roots. This one's much easier. 4x squared equals 16. Again, order of operations backwards. Before you undo squaring something, you got to undo multiplying by 4. Divide by 4. If you do it there, do it here. X squared equals 4. In order to get rid of x squared, take the square root. If you do it there, do it here. X equals, now the square root of 4 is both 2 and negative 2. So you can write 2 comma negative 2, or you can do plus or minus 2. Both of those answers, that represents two answers, both 2 and negative 2. Number 16 says write in the form a plus bi. Remember, don't be, it's been a long time since we've seen I, but remember how easy it was. All I is a means of pulling a negative out of the radical symbol. I times the square root of 49 plus 6. We know what the square root of 49 is. It's 7. 7 times itself is 7, and so it's negative 7. So what we have is both 7, both positive and negative 7 times I plus 6. But since we want to write it and make it say a plus bi, all we got to do is reverse the order. 6 plus or minus 7 times I. '17, you find in a new C. In order to find C, you take B's value, you divide it by 2, and you square it. This is B's value, 20. So when you divide 20 by 2, you get 10, and when you square that, you get 100 for that one. Okay, this is completing the square. This is what I started to do a minute ago on number 14. You have to make a perfect trinomial on the left, x squared plus 4x. It's got to say plus c. It's got to be a better c than negative 7. So in order to get rid of that, we need to move it over by adding 7. X squared plus 4x plus c is equal to positive 7 when you add 7 to 0. Again, just like the last one, we need to find c. Take b divided by 2 and square it. Our b value in this case is 4. Divided by 2 is 2. And 2 squared is going to be positive 4. But if you add 4 to one side, remember you have to add 4 to the other side. So when we put those two together, we get 11 equals. Now you got a perfect trinomial on the left. It doesn't do you any good to move the 11 back over. You want to take the square root of the first term. It's x. And you want to take the square root of the third term, c, and it's 2. This is the sign that goes in between them, the one in front of b. X plus 2 squared equals 11. Now you solve it just like we did a few problems ago. Get rid of x plus 2 squared by taking the square root of everything. If you take the square root of that side, do likewise here. X plus 2, this cancels out, equals the square root of 11. And then in order to get x by itself, subtract 2 on both sides. X equals negative 2 plus or minus the square root of 11. Number 19, y equals, we're rewriting in vertex form, y equals x squared minus 10x plus 18. You want to move that plus 18 over. We got to make a perfect trinomial. So when it goes over, you subtract 18 on both sides. Y minus 18 equals x squared minus 10x plus c. You need to get another c. Remember, 10 is your b value, divided by 2 is 5, and 5 squared is positive or plus 25. If you add it there, make sure to add it here. Can't ever do it to one side, not the other. So y minus 18 plus 25 becomes y plus 7 equals. Take the square root of this is x. The square root of this is 5. This is the sign that goes in between a minus, and it's a binomial squared. Almost vertex form. One more thing you got to do, get rid of plus 7 on both sides by subtracting it. When you subtract it here, y equals x minus 5 squared minus 7. Vertex form. 20 says, write this as a polynomial in standard form. Just FOIL it. First two terms, x times x, or x squared. Outer two terms, x times negative 3, negative 3x. Inner two terms, negative 6 times x is negative 6x. Last two terms, negative times a negative is plus 18. Combine your like terms, negative 3x and negative 6x, and you get negative 9x. X squared minus 9x plus 18. It's in standard form because it's counting down x squared, then x to the first power, and then a constant term with no variable. 21 says divide using synthetic division. Remember, with synthetic division, you're using the opposite of this negative 4 here, of this negative 4 here. So in your box, you put a positive 4. Check all of your degrees on your exponents, 4, 3, 2, 1, no exponent at all. Make sure that you didn't miss one. If it ever misses one, if it ever skips one, you have to represent that with a placeholder of 0. But it doesn't skip one in this case. What are the coefficients for all of them? The first coefficient is 1. The second coefficient is negative 16. The next one is positive 54. The next one is negative 31. And the last one is positive 28. Draw yourself a line. Remember, for the first one, it just comes straight down and becomes 1. Then you multiply it times that 1 multiplies times 4 in the box. You keep going back to that, and that's what goes here. Negative 16 plus 4 is negative 12. You go back to that box every time. Negative 12 times 4 is negative 48. When you combine those two, you get positive 6. Again, you go back to the box every time. 6 times 4 is positive 24. When you combine those two, you get negative 7. One more time, back to the box. Times 4 is negative 28. We get a 0 in our remainder spot. From there, you're going 1 degree less than x to the 4th. So this first coefficient, 1x, it becomes to the third, 1 less. We go to this one, minus 12x squared. You just count down. Positive 6 plus 6, x to the first power, minus 6. And there's no remainder. So plus 0 over x minus 4 is unnecessary. X to the third, minus 12x squared plus 6x minus 6. Simplifying the difference, 2w squared minus 7w minus 8 minus 3w squared plus 5w minus 4. We're subtracting right here. 2w squared minus 3w squared. Make sure, remember, you can only add and subtract like terms. They have to have the same variable raised to the same exponent. 2 minus 3 is negative 1w squared. Negative 7w minus, again, positive 5w. So negative 7 minus 5 is negative 12w to the first power. And the last one, negative 8 minus again, negative 4. Negative 8 minus a negative 4 means plus 4. Negative 8 plus 4 is minus 4. Negative w squared minus 12w minus 4. 22 is simplify the product. You multiply 5 times 3 and get 15. A to the 5th times a to the 3rd. Remember, anytime you're multiplying the same basis, you add 5 plus 2. That gives you 15a to the 7th. For the other one, you do 5 times negative 3, and you get negative 15. Notice it's a to the 5th and b to the 3rd right here. You don't add the exponents when it's different bases like that. You simply write a to the 5th, b to the 3rd. 15 a to the 7th minus 15 a to the 5th, b to the 3rd. 24, simplifying a radical expression. The easiest way to do this is to take 56 and divide it by 2. You get the square root of 28. When you separate that, you want a perfect square that goes into 28. We know 4 is one of the perfect squares. It multiplies by 7. So the square root of 4 is both positive and negative 2 times the square root of 7. 2 square root 7, both positive and negative. 25th, multiply 3 plus the square root of 10 squared. That means 3 plus the square root of 10 times 3 plus the square root of 10. FOIL, 3 times 3. 3 times the square root of 10 plus 3 square root of 10. Square root of 10 times 3 plus 3 square root of 10. Square root of 10 times square root of 10 plus the square root of 100. We know what the square root of 100 is. That's plus 10. So combine your like terms. 3 and 10 is 13. And 3 square root of 3 3 square root of 10 plus 3 to the square root of 10 is plus 6 times the square root of 10. 26, graph. There's a negative right there. Y equals negative 2/5 x plus 2. Y equals mx plus b. Algebra 1. Begin at 2, at 1, 2. That's where you begin. Your m is negative 2 over 5. Tells you to go down 2 and to the right 5. Down 1, 2 over 1, 2, 3, 4, 5. Second point's right there. You have 2 points. Connect them. Your graph looks like that. Y equals mx plus b. Slope-intercept form. And that's it.